I'm Luke, and in this diagnostic module, we're going to take a look at catalyst efficiency. Poor performance, running rough, or an engine light could be symptoms of a failed catalytic converter. Let's go through the procedure to diagnose this fault. Using a scan tool, I have a P0420, catalyst system efficiency below threshold, bank 1. It's a good idea to check for codes in other modules before proceeding with the emission-related faults, as some systems can log this fault. For example, an engine misfire. Take the time to look at freeze frame data, as this information is vital when diagnosing. Because we're dealing with an emission fault, we need to have the engine at operating temperature and in closed loop. Let's look at the live data. I've selected the downstream oxygen sensor. If we take a look at the sensor, you will notice the signal is fluctuating, where it should be a constant voltage. The downstream oxygen sensor isn't the issue. This is because the sensor readings are changing and there isn't a DTC for the downstream sensor. We need to investigate further. Always start with the basics. I'll check the exhaust system. The most effective way to check an exhaust is to use a leak detector with the engine off. If you haven't got one, you can listen for any odd noises whilst partially blocking the tailpipe with a damp rag with the engine at idle. I'll carry out the second method by using a damp rag. When carrying out these tests, make sure you wear safety glasses and heat gloves. I'll get David to block the exhaust and I'll check the system. There doesn't seem to be any leaks. Now we need to check the catalytic converter. We can do this with the engine on or off, using a soft hammer, gently tapping the catalytic converter. It doesn't sound right. Abnormal noises can include rattling and metallic sounds. A normal operating catalytic converter is usually much hotter at the outlet compared to the inlet. A chemical reaction that takes place within the catalytic converter creates much higher temperatures after completion. Using a digital infrared gauge, just like this one, I'll check the catalytic converter on the inlet and the outlet and compare the different temperatures. You can see that the temperature is around 320 degrees at the inlet. And the outlet is around 290 degrees. This is too cold. The outlet should be much hotter. If the readings are inconclusive, increase the RPM to 2000. This will cause the temperature within the converter to rise quicker, giving you a better result. This is conclusive evidence that the catalytic converter is faulty. Let's switch off the engine and replace it. Now that I've removed it, you can see that the converter has collapsed. That was the cause of the downstream voltage fluctuations. High kilometres and age of the vehicle would have been the most likely cause, as there were no misfired DTCs present. If the converter was melted, the cause could have been the engine getting too hot or an engine misfire, adding too much fuel to the faulty cylinders, making it run rich, therefore saturating the catalytic converter. Now that the converter is replaced, it's essential to recheck the exhaust system for leaks. Thanks. Then check for faults after clearing all data. Once this is all done, make sure you carry out the correct drive cycle for your vehicle's catalyst system. Checking the readiness monitors will confirm that the catalyst monitor has been completed. That's Catalyst Efficiency Diagnostics. Checking freeze frame and live data will help with your diagnosis. Don't be afraid to ask the customer lots of questions relating to when the fault occurred. And remember, keeping up to date with technology is essential in today's automotive industry. Bye for now.